This is a play on Asimov's four laws of robotics. He had three laws and he added a fourth one, which is called the Z law. So I took it and there's a whole article about this. How do we apply it to the building industry? So the first law is about safety and responsibility, that AI must protect people and infrastructure. And if we're going to give tasks to AI and robots, we can't have them damaging the infrastructure. The second one is about ownership of control. It's basically governance, right? Which is very much about ISO 55,000. If you don't have governance, then things can go wild, right? Third one's about resiliency and interoperability, that the systems must work with each other. Each of these laws references the first one, says you can do this one as long as you don't break this other law. So it's kind of working its way down. And the last one's interesting. It's about wisdom and long-term thinking to serve humanity's future. And I think it's very applicable to what we're trying to do in the industry. Just like we saw last week from Basil, machines talking to each other to optimize energy use. And there's no dashboard. It's basically data going back and forth of machines optimizing energy. But the rules that are written around that are written by humans to say, well, here are what we want you to do to optimize energy.
Of course, come on, this goes back to what you did with LACCD regarding the now 77,000 work orders that were brought into ChatGPT and analyzed in AI. And that was just a remarkable success of how data can be used, as long as the data is there.
This is a very real application that is achievable. People can put their work orders, their collected work orders into AI and turn it into predictive maintenance. That's transformative.
And also the other thing relating to that, too, this, if we start getting more serious about the data. So obviously a lot of this stuff, we got questions like the conference, right? Cybersecurity and privacy and all that. We're loading stuff into ChatGPT, right? It goes to their server. But what we learned, got confirmation at the Scale conference, is that you can bring AI agents to the edge. In other words, our devices now are supercomputers that can have AI loaded in them. And if you imagine one of these devices in a system inside the building, then it could be communicating with that system inside the building. So you're not always having to send things out, which is a very important point, because these AI tools, they use a lot of energy, and sending them to a central server, it's just ballooning the amount of energy that's using. That's just not sustainable. But if we think in terms of breaking it down to smaller pieces that have very specific tasks, they don't have to know everything about the world to balance a rooftop unit like Heath showed. It's a very precise set of instructions. Same thing with work orders. We could say, go and look at patterns in these work orders that might be a risk in certain part of the building. You describe that as essentially a prompt that you put into the agent that works with other agents to look for things that might need to be reacted to, whether it's a work order or preventive maintenance. We have an event on April 22nd where Cyril and I will go into more details. Today was more of an introduction. We want to take a deeper dive on April 22nd through ALM on more of this connectivity between these different systems and digital twins and the use of AI as well. I think it's even more important now to get the owners and the governance in here.
Yeah.
Because a lot of owners are not engaged enough in understanding the technology, and kind of push it to the IT department. Oh, go figure this out. This BIM stuff or this digital twin stuff or this AI stuff. And that's the wrong thing to do right now. We need some owners leading this, because they're the ones that are wanting the total cost controlled. Therefore, they should be writing these requirements and understanding even what to ask for. Because I've seen pattern of it over and over again. They're asking the wrong questions because they've been fed a lot of marketing or a lot of misconceptions, and it's just time for that to stop, because it's not only bad practice, it actually gets dangerous now if we don't help guide that evolution that's going to happen with systems starting to talk to each other more. For example, we want systems to talk to each other. Okay, that's not just going to happen accidentally. We have to have some kind of method to do that, which actually gets into the Coalition for Smarter Buildings and IBB and the Linux Foundation work that's happening as well, to create these open source connections so we see how things are talking to each other. And that's really the only way to scale it, because there's so much complexity in all this. How do we tell that story to owners so we don't get them bogged down with BIM and digital twins and IFC, and all that stuff's important. But I think we create a lot of noise ourselves that we can't even understand what we're talking about yet, let alone tell that story to an owner that's going to be paying for this. So we really need to figure out how to tell that story and how to show the benefits. And now I think with these technologies, it's going to, first of all, be easier to tell stories if we're part of that. Second, I think with the technology, even with AI, this is actually a good example that I kind of touched on earlier. AI actually helps you go through a lot of data quickly. So it's good to have structured data for AI, but it also allows you to look through non-structured stuff to make sense out of it and make it more structured, or to on the fly create apps like I mentioned from the Scale conference. It's a completely different world where you don't have to plan on building an app for a year and then build it for 2 years and then release it. And then by that time it's outdated. It's just apps become disposable. Basically, you build apps and you plug them together and you create solutions, and then you have AI helping you manage essentially that complexity.